to Maths with Mrs. Hammond. Now this is the fourth part of our four-part series. It's a final video on finding LCM. Thank you for staying with us. Thank you for watching all three videos if you've done so already, and if you haven't already done so, I'm going to encourage you to follow the links at the top so you can watch all three videos. And today's video is going to focus on finding the LCM of numbers using the division method. Now this is a very uncommon method, but because Maths with Mrs. Hammond is about presenting different ways of solving simple problems and complex math problems, so that's why we're presenting this division method that's not often used, but it's a very powerful, very useful method, particularly when you're dealing with really large numbers, where you need to pause the video as many times as you need to and try the examples on, and just try again until you get it. I'm sure you will get it eventually. Before I carry on, I'd like to say please do like the video and subscribe to this channel. Also share with your friends. Okay, so here's the first example. I've got 24 and 60. Now what I'm going to advise is if the two numbers you're finding LCM of are even numbers, of course you know every even number is divisible by 2, so I would like you to please find as small a number as you possibly can, a smaller factor, shall I say, as you possibly can, to divide through the two numbers. So this is what you then do. You need to draw your lines, columns, and then have the two numbers. And of course we're going to use 2 as our first common factor. Now we're not using the highest common factor or the lowest common factor, that's not it, but we're just finding the smallest number that could possibly divide through the two numbers we have. Sometimes it might be 3, it might be 5, it might be 7. Okay, but we want a factor. We want a prime factor. Yes, we do want a prime factor. Okay, not just any factor. All right, a prime factor. So I have 2. So I'm going to divide 24 and 60 by 2. And then another common factor of 12 and 30 is 2. All right, I'm going to divide both numbers by 2. And a common factor of 6 and 15 is 3. I'm going to divide both numbers by 3. Now I have 2 and 5. Now 2 and 5 are both prime numbers. They do not have a common factor. So you will always, most of the time you will get to a point where you have 2 prime factors that do not share a common factor. So there's nothing to worry about. So what we'll do is that we'll then individualize the division process. What do I mean by that? I'm going to take each number in turns. Now what's the lowest prime factor, okay, that can divide through the number 2? Of course it is 2. So I'm going to divide 2 by 2, and that's going to give us 1. But we're not going to divide 5 by 2, so I'm just going to write down the 5 as it is. So please feel free to pause the video at this point and go over what I've just done here. This is where a lot of students get things mixed up and confused, but there's nothing to be confused about. Now we've taken care of 2 and we've ended with 1. When you find a quotient of 1 after your division, then you need to stop at that column. So that's the end of the road for that column. Now we need to go on to 5. Now the smallest prime factor that could divide through 5 without a remainder is 5. So 5 divided by 5 is 1. So there you have it. So we've ended with 1 for both numbers. So our LCM is just the product of all the numbers, all the prime factors listed to the right. So that's 2 times 2 times 2 times 3 times 5. Now to give us 120, which is the LCM of 24 and 60. Now you'll notice on the right, on the table, I have 2 and 2 and 3 and 2. But writing out the numbers, the factors as a product of to give us the LCM, I have put together all the 2's. Now it's just for presentation purposes, okay? I mean, it really doesn't matter if you write the 2 before the 3, but it's just good practice for you to organize your numbers in ascending order. Okay, so that's why I have all 3 lots of 2 put together, then followed by 3 and 5. So there it is. That's just how to find the LCM using the division method. So Again, you divide the numbers you're given by 2, and you then carry on. All right, so you get the point. So feel free to pause the video and go over it one more time. So here's your example. You just try this and we'll work through together. Okay, so I'm going to draw the same table. Yes, at 12 and 18, of course 2 will divide through 12 and 18. That's the smallest prime factor that will divide through 12 and 18. So that's giving us 6 and 9. Of course 3 will go through. Now yes, we could use 3 at this point, as you can see, but somehow we've chosen to use 2. Now it's a deliberate, act, just so you can see that if we divide by 3 or 2, either way we will get our answer. So let's see how far 2 takes us. Of course we can't divide 9 by 2. We can only divide 6 by 2. So let's see where that leaves us. So 6 divided by 2 is 3, and we're not going to divide 9 by 2 because there's going to be a remainder. So we're going to just write down the 9 that way. Now you can see we have 3 and 9. Of course, a common prime factor that can divide through 3 and 9 is 3. So we will divide by 3. Right? So that's going to give us 1 and 3. So as you can see, we've gotten to the end of the road for 12. Now we've hit 1. So it means we cannot divide 1 any further. But we have 3 on the column for 18. So it means we can still do one more division to give us an answer of 1. So that's it. So our LCM is just simply 2 times 2 times 3 times 3, which will give us 36. So here's the extension. We've got 3 numbers. Pause the video and attempt this question. Okay, so we'll just go through the same process. Okay, now here's a bigger table to accommodate all 3 numbers. And of course we'll start with 2 and another 2. Right, and then we've tried another 2. Now even though we can't divide 9 and 15 by 2, but of course we can divide 8 by 2 without a remainder. So this is what we're going to do. So we've divided 8 by 2 to give us 4, and then of course we've got 4. We're going to run through divide 4 by 2 again, but remember 9 and 15 will be retained because we cannot divide 9 and 15 by 2. So one more time, we've divided 4 by 2, so we still have 2. We cannot divide 9 and 15 by 2, so we've retained 9 and 15. Now we've hit 1 on the 32 column, so that's the end of the road for 32. Now we then need to deal with the 9 and 15. So of course a common prime factor that will divide through 9 and 15 is 3. So that's giving us 3 and 5. And we're going to use 3 one more time. So that's the end of the road for 36 as well. So we then need to deal with 5 until we hit 1. That's our target. Okay, now we've hit 1 on all 3 columns. So now we can put together our LCM by writing out all the prime factors to the left of the table. So we have 2 times 2 times 2 times 2 times 2 times 3 times 3 times 5. In other words, that's 2 to the power of 5 times 3 to the power of 2 times 5 to give us 1,440 as the LCM of 32, 36 and 60. So here are a few questions for you. Feel free to pause the video, try these questions and use other methods previously explained on our first 3 videos and improve your skills on finding the LCM of numbers. Now we've come to the end of our 4-part series on finding LCM. If you haven't seen the first 3 videos, please go onto our channel and watch all 3 videos and to consummate your understanding of how to find the LCM. And of course, do remember to like our channel, like the videos and subscribe to our channel, and of course share with your friends. So thank you so much for watching today's video, and watch out for more enlightening, educative videos on our channel. That's Maths with Mrs. Hammond. Thank you so much for watching. Bye for now.